Good evening, everybody. Can you all hear me? Very good evening to all of you. If you can hear me, please say yes. Awesome. All right. Sorry for the slight delay. Just setting up the system and everything. How's everyone? All right. Those watching on YouTube, please hit the like button. I'm good. Thank you so much for asking. Thank you, guys. How's everybody else? How's the preparation going? Which part are you feeling confident about, not confident about, doubtful about? Tell me. Channel name Edyst. Channel name is Edyst. Just go ahead and hit the like button on YouTube. All right. All the people watching on YouTube, please hit the like button for sure. Okay. Hello. Hi. All right. Just going. Somebody saying, yeah, it is. Come on, man. You're students. Students should not just be going. Just going. What is just going? Yeah, students have fun and happening lives, right? Ideally. Okay. SQL was a little tough in today's mock test, sir. Okay. Yeah, we'll get that doing. Somebody saying no sound. Is that so? Is everybody else getting good sound? Is everybody else getting okay sound? I think then in your case, able to hear you clearly. All right, that's cool. Okay. All right. Okay, so what's the part that's doubtful to you? What's the part that's getting difficult? What's the part that's not so difficult? Start the session. Yeah, I'll start the session in a bit. Okay, cool. So today we look at today's mock test questions. What are the questions you got in today's mock test? And we'll focus on the coding part. Tomorrow and day after we look at again the MCQs and SQL and so on. But let's focus on the coding part today, right? Somebody's asking, how am I? I'm good. Thank you so much for asking. I'm good as well. So what are the coding questions all of you got in today's mock test? Please let me know. Java coding is difficult. Don't worry. I'll solve questions in Java also. So what are some of the questions you got in today's mock test? So generate password, semi-prime number. What else? Any other questions you guys got? String rotation. All right. So you are all asking for this yesterday. So I'll definitely take this up today. String rotation. What else? These are the three. Anybody else got any other sort of question here? Ugly numbers. Okay. Cool. Let me open up these questions on the Edyst platform. Right. Let me just open this up. Okay. Semi-prime numbers, generate password, and string rotation. Right. Somebody saying, where can we write the mock test? I think my team can guide you on that. On YouTube, somebody's asking, how can we write mock test? Somebody's saying, I couldn't attempt the test. So are SQL questions there on the SQL platform? First of all, the test is still active. If you missed out on the test, then you can still, it's active till midnight tonight. So there's no missing out on it as such. You can go ahead and still attempt it. But yeah, the questions are still there on the platform. Yes, that's also there. But if you missed it, then it's not really a miss because it's still active till tonight. And my team, if you are already on the Edyst platform, I got this question on Zoom. So you already have access to it. You can go ahead and check out. If you're on YouTube and watching, then you may not have idea of that. So in that case, you can just my team will guide you. Beautiful function problem. Okay, beautiful function is a hack with Infy problem, and we're not covering that, but we've already covered the beautiful function problem on the Edyst YouTube channel. You can check it out there. So I've already covered it as part of last year's hack with Infy. Do check it out. So not taking that up today. All right. Let's start with the first one, which is ugly numbers. Okay. Let's start with ugly numbers. Maximum severe satisfying condition. Yeah, I'll take that. I think, I want to, okay, I'll just come to that. I'll tell you how we're going to solve that. Okay. So let's take up ugly numbers. Let's start with ugly numbers over here. Okay. All right. Before I start, somebody saying, can you please tell me if we code 2 problems, then what is the percentage that we're going to get? If you solve 2 problems, roughly speaking, that's 60%. That is what it was in the last 2 years. This year, again, you have to check out their instruction. So, and they might even change the weightage depending on their intake. One thing I know is just don't quote me on this, but just from our sources, I kind of know that the hiring intake will be much more this year, hopefully. Again, if they don't take more, then don't tell me. But just then, that's the rumor I heard, that the hiring intake should be more this year from InfyTQ and from Hack with Infy. Okay, so generally, if you are able to get both the questions right, that's 60%, and you just need to get some marks in MCQ and you're through. That's what they generally say. But don't rely on that only. Make sure you're good in both of them. All right. So a number is considered to be ugly if its only prime factors are 2, 3, or 5. That's it. Okay. So for what does that mean? That it means that it cannot have any other prime factors. It can only have prime factors 2, 3, or 5. So 1, 2, 3, 4, 5, 6, 8, 9, all of these are sequence of ugly numbers. Why? In each of them, if you check their prime factors, and you should know this, that every number that you get can be reduced to prime or can be expressed in terms of prime numbers. So any number that we get, if it's can be expressed in either terms of 2 or 3 or 5 or a combination of them, then we call it as a ugly number for whatever reason. I have no issues against that, right? But for some reason they want to call it ugly number. I don't know why. Anyway, create a program. It takes a number as n as an input and check if it's an ugly number. So I have to take a number n and check if it's an ugly number or not. The hint they've given is an ugly number can be expressed as 2 raised to a into 3 raised to b into 5 raised to c, where a, b, and c are non-negative integers. So first line contains number tc showing the number of test cases. Following tc line contains the number n, which you need to check whether it is ugly or not. So again, this is a very common way of taking input. They'll tell you the number of inputs first, and then you have to figure out how many numbers are there in each. So the number of inputs will be there, and then for each input, you have to figure out whether it's an ugly number or not. Right. So again, fairly standard thing over there to do. And yeah. So any thoughts, everybody? You got this in today's mock test. What did you guys all think about this question? First of all, everybody understood the question. As I usually say, when you get a question, first things first is you should try to see if the with sample inputs and outputs. So let me give you a few sample inputs, right? Let's say the number given to you is 13. Is it ugly? Would we call this an ugly number? And let's say the number given to you is 21. So what would you say about that? What about 50? And what about, let's say, 330? So let's go start with 13. Is it ugly? Is 13 ugly? And if yes, why? If no, why not? Why is 13 not ugly, as you're saying? Okay, 13 itself is a prime. So 13 cannot be expressed as a factor of 2 or as a multiple of 2, 3, or 5, right? So 13 itself is a prime. So not ugly, right? What about 21? 21 is multiple of 3, but you guys are saying it's ugly. Let's go back to the question again. Let's look at the definition. A number is considered ugly if its only prime factors are 2, 3, or 5. Only prime factors, right? So is it ugly or not ugly? Not ugly, right? See, again, they've also given you the hint. Can you express can you express the number as 2 into 2 raised to a into 3 raised to b into 5 raised to c? Meaning that if you're not able to do this, can you express 21? Can you express 21 as this? Is it possible to express it like this? Let's say a is 0. Let's say a is 0. So it's like 1 into 3 raised to b into 5 raised to c. So I can do 3 raised to 1, but if I do 5 raised to 0, I cannot, right? Because I'll try to express it as 3 into 7. That's what I can express at. I cannot express it as 2 as some factor of 2, as some factor of 3, and some factor of 5, right? I cannot do that. Is that making sense? Did you guys understand this part? Why 21 is not ugly? Yeah. Okay. So not ugly. What about 50? Is it ugly or not ugly? And why? All right. So 50 I can express as 5 into 5 into 2. The prime factorization is like this. The only prime factors that you see is no, it's not 2 square into 5. 2 square into 5 would be 20. It's the other way. It's 5 square into 2. Okay. But yeah, 5 into 5 into 2 is the like 50 is expressed only in terms of prime factors. It becomes 5 into 5 into 2. That means there are no other prime factors. That means it is ugly. Whenever I have a prime factor other than 2, 3, or 5, it's not ugly. So in 21, although I have 2 prime factors, 3 and 7, 7 is not 2, 3, or 5. You should have all prime factors either 2 or 3 or 5. That's what you should do. Okay. What about 330? Is it ugly or not? How do you express 330? 330 no, because of 11. Interesting. Okay. So 330 will express as 3 into 11 into 2 into 5. Correct? So 2 is a factor, 5 is a factor, 3 is a factor. But on top of that, 11 is also a factor, and 11 is not one of the prime numbers allowed to us. We are allowed only 2, 3, and 5. So this is also not ugly. Are you guys getting it, everybody? Okay. How about 750? Is it ugly or not ugly? Okay. Somebody's asking why I can't express 330 as 2 into 2 into 5 into 5 into 3. Just do the multiplication yourself. You will see why we can't do that. Okay. Is 750 ugly or not? Yes, 750 is ugly. How will it work? Just start prime factorizing it. You will get 25 into 3 into 10. If I further break 25 down, what do I get? I get 5 into 5, right? And 3, and then 10 I get as 2 into 5. So all the prime factors are either 2, 3, or 5. Right? I don't have any other prime factors. So this is also ugly. Right? So the question basically saying, if you can express in prime factors that are only 2, 3, and 5, then it's ugly. If you can get more prime factors other than 2, 3, or 5, then it's not ugly. Okay. Is that clear? Is the question clear, everybody? Okay, I'll do the quick input taking part. Let me do it in like Python first, then I'll come to Java. So let's say the test case, what it's saying is it'll give you the number of test cases. And let's say for C in the range TC, I will take the number as input, n is equal to int input. And I need to find out if this particular number is ugly or not. Okay. So somebody's given me an approach. Let me just look at the approaches. Okay. So please tell me your approach, how you'll solve it. Somebody's given me the approach, finding all the prime factors of that number and keeping in a list and finding maximum of list. And if max greater than equal to 7, not ugly, else ugly. Okay. So somebody's saying basically find all prime factors of the number, store all prime factors. And this is not the approach, this is somebody's proposed approach. Okay. Store all prime factors in a list. After I store all the prime factors in a list, if prime factor greater than equal to 7, not ugly, else ugly. Right? This is what somebody has proposed. I'm not saying this is like the only right way, but this is what somebody has proposed. Others, any thoughts on how you try to solve it? Just give me some sort of logic. How would you try to solve this? Something using OR operator. Okay. You might use OR operator, but what are you actually looking for over there? Okay, somebody's saying divide by 2 or 3 or 5 until n becomes 0. Interesting. Okay, somebody's saying while n greater than 1, we can check if n modulo 2 equal 1 modulo equal to 2. Okay. So yeah, you're all converging to the similar approach. The approach that you can follow is if divisible by 2, keep dividing by 2. What will happen? Let's say if the number is divisible by 2. If I keep dividing by 2, what's going to happen? If the number is divisible by 2, if I keep dividing by 2, then what's going to happen? 0 will not come. Remainder 1, no. If divisible by 2, I keep dividing by 2. Take any number and try to see. If it's divisible by 2, keep dividing by 2. Then what will happen? 1, no, no. Quotient, okay. Somebody saying no two factors will remain, right? Exactly correct. See, if let's say I take the number 114, it's divisible by 2. I'll keep dividing by 2. What's the next number? 57. Should I keep dividing by 2 again? No, the number is no longer divisible by 2, right? Is this number 0 or 1? Is this number 0 or 1? No, right? Are you understanding what I'm trying to say here? I'm saying if the number is divisible by 2, you keep dividing it by 2 till you get a non-even number. Can you let me know if you understood this part? Okay. So let's say I keep dividing by 2. What are the possible cases I have? Becomes 0. I kept dividing by 2. So first of all, either becomes 1, right? One of the things I kept dividing by 2, let's say it's some number like 64. I kept dividing by 2, it will become 1. Or what will happen? It will become some odd number, right? It could either come down to 1. Let's say it's a pure power of 2. 64, let's say. Kept dividing. I'm left either with 1 or it will become some odd number. Okay. Now, what we are concerned about is not whether it's odd number or not. We are concerned if the remaining number has any factors of 3 and 5. If it has any other factors apart from 3 and 5, then it is not ugly. But if it has only 3 and 5 factors, then it's ugly. Clear? So what I'll do is, whatever the number I get after this, keep if divisible by 3, keep dividing by 3. Again, what will happen? All the factors of 3 will come out. And then if divisible by 5, keep dividing by 5. Okay. See, I'll take you an example. All right. Let's say you had the number 210. Right. Let's say this is the number 210. I kept dividing by 2. What do I get? So I kept dividing by 2. I got 105. I can't go further than that. Then I divided by 3. What do I get after dividing by 3? Anybody? $35. So I divide by 2. Because I can't divide by 2 further, I divide by 3. I divided by 3. Somebody saying if n modulo equal to 0, then n equal to n by 2. Yes, that's what I'm saying. Then this 35, not divisible by 3 anymore. I'll try dividing by 5. What do I get? 7. Now I kept dividing by 2, I got a number. I kept dividing by 3, I got a number. I kept dividing by 5, I got a number. I got 7. Is this number ugly? No, it's not, because even after removing all factors of 2, 3, and 5, even after removed all the factors of 2 and 3 and 5, I still had one number left. I still had a particular number left. Okay. So this number is not ugly. But let's say if I had a number like we said 750. So what do I do? Divide by 2. What do I get? I get 375, right? If I'm not mistaken. Yeah, 375. Then I can't divide further by 2. So I divide by 3. What do I get? 125. Can I divide further by 3? No. So divide by 5, 25. Divide by 5, 5. Divide by 5, 1. I got 1 over here. If I get 1, it means that after dividing by 2 as much as I could, 3 as much as I could, and 5 as much as I could, what is happening? I'm not left with any other factors. So is this 750 ugly or not? It's ugly, right? So that's all you have to do. Keep dividing by 5. Then keep dividing by 2, then keep dividing by 3, or the other way. Keep dividing by 2, then 3, and then 5. So that's what I'll do for this particular number n. While n modulo 2 equal to 0. Let's say it's not divisible by 2, it won't even enter this loop. So it'll become n is equal to n divided by 2. Keep dividing by 2. Then while n modulo 3 equal to 0, if it's still divisible by 3, n is equal to n divided by 3. And while n modulo 5 is equal to 0, n is equal to n divided by 5. Now if I come out, if n has become 1, if n equal to 1, it means that I had only factors of 2, 3, and 5. Means that I can print ugly. Else I can print not ugly. Okay. There is one edge case here. Let me know if you guys know that edge case. But yeah, let's run this and see. N is equal. Okay, we've gone to infinite loop. Interesting. Let's see why that's the case. For which one? 8, 2, 3, 5. Yeah. For 0, we got into a time limit exceeded. For -1, also we'll get into time limit exceeded. So 0 we got in because 0 is divisible by 2. So I kept dividing by 2 again and again. So we got into an infinite loop over there. Right? So 0 is the edge case. We are lucky that they gave us the edge case. And we're saying 0 is ugly and 1 is not ugly. And -1 and all negative numbers are not ugly. Are we saying 0 is ugly? This is for 8, 2, 3, 5. And then this 0. Yeah, 0 is ugly. We are saying, okay. So if n equal to 0, print ugly. Elif 8 is the number of test cases. Yes, you are right. 8 is the number of test cases. Yes, good point. 2 is ugly. 3 is ugly. 5 is ugly. 0 is not ugly, right? 1 is ugly. -1, -2, and 420 are not ugly. Okay, so if we just do if n equal to 0, we'll say it's not ugly. Is that the case? Yeah, n equal to 0 is not ugly, and n equal to 1 is ugly. That's fine. We are anyways printing that. Yeah, n less than equal to 0 is not ugly. That's what we are saying. N less than equal to 0 is not ugly. Else, I will do all of this. Right? Now it works out. And if I submit it, it works out. Okay. Is that clear, everybody? We missed out the edge cases, which was if n is 0, n is 1, and n is -1. We missed that out. But other than that, we've got it. Is that clear? Sure. Somebody's asking once again. Happy to do it once again. Did you understand this logic that if the number has to have only 2, 3, and 5 as prime factor, then if we keep dividing by 2 and then keep dividing by 3 and then keep dividing by 5, I will exhaust all the factors because there are only 2, 3, and 5 as factors. So till I have a factor of 2, keep dividing by 2. Till I have a factor of 3, keep dividing by 3. If I have a factor of 5, keep dividing by 5. Did you understand this part? Okay. So if you got that, then all I'm doing here is I'm saying taking the number of test cases as input. For every case in this test case, what I'm doing is taking n as the input first. Now, if n less than equal to 0, I'm printing not ugly. So that's what I'm doing here. How do I know that? How do I do that over here? I am able to see that as for 0, it's not ugly. How? Let's look at the input case. Input is 8 is the number of inputs. 2 is ugly. 3 is ugly. 5 is ugly. 0 is not ugly. 1 again is ugly. -1, -2 is not ugly. Basically negative numbers, and 0 is not ugly. So I first put that as the edge case to check. If n less than equal to 0, it's not ugly. Else, keep dividing by 2. When do I keep dividing by 2? If it's divisible by 2. So if n modulo 2 equal to 0, keep dividing by 2. It will not run infinite loop because after a point, it will remove all the factors of 2. You have no more factors of 2 left. This will not be even anymore, and you're going to break out of this loop. Then you go to the next loop and try to see, is n divisible by 3? If yes, keep dividing by 3. And then if n divisible by 5, keep dividing by 5. Finally, if you kept dividing, you removed all the factors, you're only left with 1, meaning that it was something 2 into 2 into 2, then 3 into 3 into 3, and then 5 into 5 into 5 and 5, let's say. You kept dividing, you removed all the factors, you're only left with 1. If that's the case, then it means that I had no other factor, and this is indeed an ugly number. However, if I did have other factors, then n will not be 1. There will still be some numbers left. So then it will be not ugly. Right? Even if, let's say, it has only factors of 2 and 5, then it will never enter this loop in the first place. Right? So I'm saying it should have all factor 2, 3, 5, or any of these 3 can work. Any of them can work. The point is, if let's say it's only 2 factors, let's say it's only like 2 raised to 3 or 2 raised to 7, let's say, then also it's ugly because it has only 2, 3, or 5, right? It's having only factors of 2. So the question says a number is considered ugly if its only prime factors are 2, 3, or 5. So any one of these or even one of these, it's a problem. Okay. Understood by everybody? What happens if we now got the number divisible by 5 first? It's the same. See, multiplication does not happen in order, right? So if you take 750, you divide it by 5 first also, it's not a problem. Let's say you're at 750. Multiplication never really cared about the order, right? 1 second. 750, let's say you did something like this. 750, let's say you started dividing by 5. Not a problem. Divide by 5 will be what? 150. Again divide by 5 will be what? 30. Again divide by 5 will be what? 6. Then you can divide by 2 if you want. You got 3. And then divide by 3 if you want. You'll get 1. So at the end, you will have only 1, 2, 1, 3, and 3 5s, just like you had here. 3 5s, 1, 2, and 1, 3. The order will not matter. Somebody is asking, will the proposed approach work that you had proposed? Yeah, it will work. The only issue with the proposed approach is you'll have to keep finding a prime number. And when do you stop finding the prime number? That's my point. You'll try to go through all of the prime factors and you'll keep trying to find the prime factors in the proposed approach. So that's a very tedious task to keep finding all the prime factors of a number. Can it be done with OR? You cannot have a while loop with like all these conditions in an OR. So it's not just a simple OR statement. You have to use a while condition, while loop, I mean. Okay, if you've tried the proposed approach and it worked for you, good. That's also correct. It will work. So somebody saying this was actually an easy question. We were just required to use a little bit of logical thinking. Now after you explained it, it is looking easy. See, any mathematical questions, any particular mathematical questions will always be simple if you apply the maths brain on it, right? So you just have to apply your maths brain on it. The issue with InfyTQ is sometimes they will give you a lot of cleaning questions. First, you have to clean the data, like split the string, this and that, and then do it, right? Okay. Let's go quickly to the Java implementation. I thought Java would be pretty straightforward because even in Python, it's roughly the same thing only. Let me just take this. It's actually almost the same thing in Java, but let's quickly do it. It's exactly the same. That's what I'm saying. So we can do it, but I can actually just copy paste roughly the same thing. Okay. And if I did this, the only difference that it's going to change is it's not TC's int input. It's like, but this you guys already know. It's scan.next int TC for int c equal to 0, c less than TC, c++. What this is going to do is it's going to take all of the elements, right? It's going to take all of the elements as input. So it's going to go through the number of test cases. Then in that particular test cases, what you're going to do is int n is equal to scan.nextInt. Scan.nextInt. Yeah, I didn't initialize the scanner. 1 second. Okay. Then if n less than equal to 0, I'll just print ugly. And I don't just do print, I do system.out.println. Right? Else, I'm just going to put the else statement here. What do I do? Else, while n modulo 2 equal to 0, n divide by 2, while n modulo 3 equal to 0, n divide by 3, and while n modulo 5 equal to 0, n divide by 5. If n equal to 1, print ugly, else print not ugly. There's no print, so system.out.println. Right? So the logic is pretty similar, if not exactly similar. Where is this thing? Yeah, okay, cool. So if I run this, semicolons after n by 2, cool. Yeah, semicolon, semicolon, semicolon. Yeah, n modulo 5. Yeah, no colon here. Yeah, works out, and this also works out, I guess. Okay. So Java students, the logic is pretty much the same. If you want me to repeat it, I'll repeat it. But shall we move on to the next question? The only difference here is the way you take input. You do scan.nextInt. That was the only difference in the logic. All right, let's go to the next one. What is the time complexity of this code? What is the maximum? I think it'll run in a constant time, right? What's the maximum number that you can store in a in an integer. Let's assume that it's integer. What's the maximum number you can store? 2 raised to 32 something, right? Let's say unsigned integer. So you will run this maximum how many times? 32 times. If not, then you'll run it probably 64 times, right? 2 raised to, because you'll keep doing this, right? So let's say it's a 64-bit unsigned integer. Then you'll run it 64 times. But you cannot run more than that. So any integer will be, at max, it will be 2 raised to something, right? 2 raised to 64 or something. So you'll run at max 64 times. It's constant time, basically, this time complexity. You don't need to worry about time complexity for InfyTQ, but still, since you asked, I'm telling you. So I got TLE for brute force approach. I don't see how you could have got that. You must have, I really don't know how you got that actually. So please do put it on the forum. I'll check it out. Okay. All right, cool. Let's go on to the next one. Let's look at the semi-prime numbers. Somebody saying a rotation. Okay, we'll finish this maths questions off first, and then we'll go to the next one. Okay. Let's finish this one off first. Let's finish all this off, and then we'll go to the next one. Okay. A semi-prime number is a natural number that is a product of two primes. It has to be a product of two primes. They need not be necessarily distinct prime numbers. So, for example, 2 into 2, which is 4, is a semi-prime number. 2 into 2, 4, because it is two prime numbers, right? 57 is a semi-prime because it is a multiplication of 3 into 19. Oh, it is it? I was assuming it's not. Anyways, so 57 is 3 into 19, right? 121 is 11 into 11. It's a semi-prime. 186 is not, because I cannot reduce it down to two prime numbers multiplication. I will get three prime numbers multiplication, 2 into 3 into 31. Write a program to generate all the semi-primes up to a given number inclusive. So, for example, I'm telling you, let's look at the input cases. First line contains integer e, the t denoting the number of test cases. So t is the number of test cases, 2 test cases, and then you're getting 10 and 8. What is 10 and 8? Okay, so up till 10, you have to generate all of the semi-prime numbers. And here up to 8, you have to generate all the semi-prime numbers, which is 4 into, so you'll get, if you try to generate all the semi-prime numbers till 10, it will be 4, 6, 9, and then 10, right? And same thing with up till 8. How? Let's say, for example, I generate all the semi-prime numbers. If I'm trying to generate all the semi-prime numbers, I will have, let's say I give you the number 11, or not 11, let's say 20. Can you generate all the semi-prime numbers till 20? The easiest way to do it is to actually check. 1 is not a semi-prime. 2 is not a semi-prime because it itself is a prime. 3 is not a semi-prime. Again, it itself is a prime. 4 is a semi-prime because 4 is 2 into 2. 5 cannot be, it itself is a prime. 6 is, it is 2 into 3. 7 cannot be. 8, what about 8? 8 is 2 into 2 into 2, cannot be a semi-prime. 9 is a semi-prime, 3 into 3. 10 is 2 into 5, both primes, so 10 is a semi-prime. 11 cannot be. What about 12? 12 is 3 into 3 into, 3 into 2 into 2, again cannot be. 13 cannot be. 14 is a semi-prime, 2 into 7. 15, what about 15? Is a semi-prime. 15 is a semi-prime. 16, 4 into 4, no. 17, no. 18, no. 19, no. 20, no. So these are all the semi-primes you have, right? $21, yeah, 21 is, but I'm looking at only up till 20. That's what they're going to give you, up till 20, right? So they're going to give you up till 20 only. All right. How would we solve this question? It's a good question. How would we solve this question? Please do give me your approaches, your proposed approaches. It's a good question. This will come as a second question usually in your test. It will not come as the first one. It will come as a second question usually. Somebody saying we should write logic for finding prime factors. Okay. So, all right. So some of you are saying that in question, is it mentioned to take till 20? No. In question, they will give you till where you have to take. I am saying, imagine it's 20. In question, it says it could be taken 10, it could be 8. I'm saying, if you took 20, then what will be the answer? Just like in every problem, what I do is I give you a sample input, right? So I just took a sample input 20 and I was trying to think of the answer in that way. All right. So some of the proposed approaches. Number one, take all. So start from. Somebody saying, can you please reconduct the test for me? You have to just email team@edyst.com. They'll help you out with that. Just email team@edyst.com. They'll help you out. Okay. So somebody saying that, take all numbers from, I can actually start directly at 4, right? From 4 till given n. Why can I start at 4? 1 is not semi-prime, 2 is not semi-prime, 3 is not semi-prime, 4 is the first semi-prime number. So I can take all the numbers from 4 till n. This is the proposed, somebody's proposed. I'm not saying this is the right one, but somebody's telling this. Take all the numbers from 4 till n. For each number, check number of prime factors. If prime factors greater than 2, then not semi-prime, else semi-prime. Okay. Is this one of the proposed approaches? Are you guys clear with this one? Basically, I'll start with, like, I would go to 20, right? So I'll start with 1. Now I'll start directly with 4. I'll try to get the number of prime factors. Number of prime factors are 2 and 2. There are only 2 prime factors. Okay. If prime factors is greater than 2, then it's not semi-prime. Else it's semi-prime. Yeah, it's not greater than equal. It should be greater than. Basically, if you have only 2 prime factors, then it's semi-prime. That's what we're saying. So for 4, it's just 2 and 2. Okay, great. It's semi-prime. For 5, what do I get? 5 and 1, not semi-prime. 6, I get 2 and 3, semi-prime. 7, I get 7 and 1. So 7 and 1 is not a prime number. I just get 5. For 7 also I get 7, not semi-prime. For 8, I get 2 into 2 into 2, not semi-prime. 9, I get 3 into 3 is semi-prime. It has to be only 2 prime numbers. 10, 2 and 5, again, semi-prime, right? So I can basically generate all the numbers from 4 till the given number and check how many factors it has, right? Will this approach work, everyone? Yeah, so let's do something. Prime factors equal to 2, then semi-prime, else not semi-prime. If it's equal to 2, then only it's semi-prime. Otherwise, if the number of prime factors, all right, do you guys think this works? This approach? Okay, this is one way, but I'm telling you right now, this is a very lengthy way. Imagine for each number, you're continuously finding the prime numbers. For each number, you're continuously finding the prime number, right? The number of prime numbers. Like, just imagine when you come to 10, you'll again check with all the prime numbers, right? What are all the prime factors? With 14, you'll again check and so on, right? So it's a lengthy way. You guys can try this. It's a lengthy way. I want to tell you a little bit better approach than this. let's try to think of a slightly better approach than this one. Okay. So better approach. Let's try to think of a better approach. Okay. Let's say I know all the prime numbers for 20 till up till 20. Let's say I try to find out all the prime numbers up till 20. Okay. What are all the prime numbers up till 20? Let's say it are 2, 3, 5, 7, 11, 13, 17, 19. These are the prime numbers up till 20. Correct? What are the possible combinations of each of these prime numbers? How many possible combinations can I have of each of these prime numbers? How many are there, by the way? 1, 2, 3, 4, 5, 6, 7, 8. 8 are there, and the number can multiply by itself also. So how many possible combinations can I get? Okay, let's think of it. 2 can multiply with 3, 5, 7, 11, 13, 17, and 19. And with itself. So 2 has about 8. 2 has about 8 possibilities. Correct? 2 has 8 possibilities. Then 3 can multiply with 2, but we already took care of that. So 3 can multiply with itself. 3 can multiply with 5, 7, 5, 7, 11, 13, 17, and 19. 3 can multiply with all of them. Right? So how many possibilities are there with 3? 7. Do I multiply into 7? No, I say plus 7. Right? So how many possibilities? I'll have 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 possibilities, right? For 2, there are 8 possibilities for and plus 1, right? These are all the numbers that are possible. So like finally you have 19 into 19 left. That's it. So 2 can multiply with 2, then 3, then 5, then 7, then 11, 13, 17, and 19. 8 possibilities. 3 can multiply with itself, then 5, then 7, then 11, then 13, then 17, and then 19. Then 5 can multiply with itself. So it's not 8 factorial. It's 8 plus 7 plus 6 plus 5. It's not 8 into 7 into 6. It's not like that. Which is basically what, everybody? It is n into n plus 1 by 2, right? This is the, if you guys remember this. Yeah. The sum of natural numbers, which is basically 8 into 8 plus 1 by 2. Okay. So can you once explain about what possibilities you're talking about? Okay. See, a semi-prime will form when 2 prime numbers are multiplied. If 2 prime numbers are multiplied, I'm trying to say that, okay, less than 20, what are all the prime numbers? These. I'm trying to see what are all the possible combinations of these prime numbers being multiplied. That's what I'm doing. Okay. So that's what I'm trying to see. But as somebody mentioned, if you look at 2 into 17, it's 34. It's greater than 20. It's not even a, let's say, even if I generate 34, it's not a great semi-prime number because it has to be less than 20. Okay. Right. Okay. So what should I do over here? I should try to take only those numbers. I should only try to take till that prime number where the number will still be less than 20. For example, when I take 2, what all numbers can 2 multiply with before becoming greater than 20? I can do 2 into 2, 2 into 3, 2 into 5. Come on, everybody. Tell me which number can I go till max? 2 into 7. Can I go 2 into 11? Can I go 2 into 11? No, right? I cannot go till 2 into 11. I can only stop here. So 2 will contribute 4 semi-prime numbers. 2 is going to contribute 4 semi-prime numbers from multiplication with 2. Let's take with 3. 3 will go till where? 3 will be able to go till where? 3 can do 3 into 3. 3 into 5. Can it go 3 into 7? No, right? Yeah. So it won't be able, so 3 will be able to give us 2 semi-prime numbers. 2 semi-prime numbers. What about 5? Can I even do 5 into 5? No. I can't do 5 into 5. What will I go at 5 into 7, 5 into 11? I can't even go further than that, right? Same thing with 7, same thing with 11, same thing with 13. So totally I have how many semi-prime numbers? I have 6 semi-prime numbers. That's it. And the question is also only asking, it's asking us to generate the sequence. So we'll generate the sequence, but we have 6 semi-prime numbers over here. Okay. I think this will be slightly better. What we'll do is we'll generate all the prime numbers, not even up to 20. Rather, we'll not even generate all the prime numbers till 20. Till which prime number should we generate? What do you think? Till which prime number should we generate for us to understand? Because see, 7, 11, 13, 17, 19 are all not 7. Sorry, 11, 13, 17, 19 are all useless to us. Because they are never, in fact, giving us anything. Somebody saying 100. Why 100? Yeah, if we would have stopped at 7, it was good for us, right? Because 11, 13, 17. I'm talking about 20 only, everybody. For 20. For 20, where should I have generated till? If I would have generated till 7, I would be happy. Basically speaking, what is the maximum semi-prime number I'm going to need? The maximum semi-prime number I'm going to need is n divided by 2. Because this 2 will multiply into that n divided by 2. Any other bigger prime number, let's say 3, cannot even multiply into n divided by 2. It will give a bigger number than n. So for example, if 3 had multiplied into, let's say 7, I'm getting 21. 2 could still take up with 7. 2 could still take up with 7. But the moment you go above 2, sorry, the above 2 to 3, 3 can't even take up with 7. So at max, try to generate all the prime numbers between 1 to n by 2. Let's generate all the prime numbers between 1 to n by 2. That's what we should be doing. Okay. So the approach we'll do is as follows. Take input, all right. For each n, what we're going to do, we're going to say generate all prime numbers from 2 to n by 2. First, generate all the prime numbers from 2 to n by 2. For each prime number, generate for each prime number, what are you going to do? Generate all possible semi-primes. Okay. How will you generate all possible semi-primes? You will combine it with every other prime number that is possible to me. So just like this, in for 20, what I would do is I would generate only up till 7. Okay. Then for each, for 2, what will I do? I'll generate all the semi-primes. So I'll get 4, 6, 10, 14. For 3, I'll do 9, 15. I don't do 21 at that point. And then for 5, I cannot do anything. And even for 7, I cannot do anything. Right? So I actually just stop there. Does that make sense, everyone? Are you guys getting this? So I said no semi-prime for 5 and 7 because 5 I will start multiplying with itself first, which is 25. And if I do 25, then it's already greater than 20. Okay. Hence, for 5 and 7, I'll not get anything. Okay. So let's take first one step at a time. First, let's take like the number of input. Let's go here. I'll quickly do it in Java, so in Python, and then we'll go ahead. So int input is the number of test cases for C in range TC. Okay. What are we doing? We're taking n is equal to int input. Okay. Now what I want to do is I want to generate all. We want to generate all of the prime numbers from 2 up until n, right? So I'll say, for example, primes is equal to this. I'll go from 2, not up till n, till up till n by 2. So I'll say for, let's say I in range 2 up till n divided by 2 plus 1, by the way, plus 1. Why plus 1? So that I actually include n by 2. If you are a Java student, don't worry in this. There's no way of doing less than equal to in Python. That's why I have to do plus 1 over here. So that it actually goes to n divided by 2. Okay. So for I in range 2 from n by 2 all the way there, I'll check if is prime I. If I is indeed a prime, I will add it to primes.append I. I will add it. Now what is prime? I'll create a function is prime. So if let's say I is prime, I'm going to add it to my primes list. Then what do? Now I'm going to go through this primes list. Okay, sorry for this. Yeah. So now I'm going to go through my primes list. 1 second. Don't know why that happened. And why that happened. Okay. Anyways. So yeah, anyways, cool. So coming back, my flow got broken a little bit. Anyways, coming back. So for I in range 2 to n by 2 plus 1. Second, is there some issue? No. Okay. Number of test cases are given. Yeah, we've taken that. And then we did this. N is equal to int input. I took that. Primes is this. Okay. So I got, coming back. So I got my list of primes. Now, what do I do with the list of primes? I will go through them and I will keep checking if they are. So I'll keep a new semi-primes list. Semi-primes is equal to this. I'll go through my primes list. So for I in range len of primes, I'll go through that. And I'm going to check for each particular element. I want to multiply it with all the other elements. Okay. So for j in range, starting from I up until len of primes, right? I'm going to say, let's say current number is equal to primes of I into primes of j. Okay. If current number is less than n, if the current number that I have is less than or equal to n, I will append it to my semi-primes. So semi-primes dot append current number. Else, let's say it's not less than equal to n, then just break out, because if I didn't get anything now, I'm not going to get anything later on also. This is this condition. If I'm multiplying 2 into 7, I got 14. Great. Now I multiply 3 into 3, 9. Good. 3 into 5, 15. Good. 3 into 7, 21. Not good. Break out right now. Then I go to 5. 5 into 5, 25. Not good. Don't even bother checking 5 into 7. Just break out over here. That is what this condition is about. Okay. So anyways, I'll break this. Yeah. And then I just need to sort the semi-primes. Semi-primes dot sort. And for x in semi-primes, print x and is equal to space. Okay. And finally print. Okay. Yeah, we didn't define is prime. We have not defined is prime. So let's define this is prime function. for a given n, if I have to check if it's prime. This you should all know by heart, how you can actually check if a number is prime or not. If n less than equal to 1, then return false. If n equal to 2 or n equal to 3, I like to check these ones first. Or n, yeah, like this, I just return true because it's just faster. And then what do? I start from, for I in range, you start from 2, go up till square root of 2, right? So sorry, square root of n, that's the fastest way. So I can go int of square root of n plus 1. I keep going till there. If n modulo I equal to 0, return false. However, if I could not find anything in this up till square root, then I'll return true. Okay. So that's what I'll do over here. Now let me try to run this. Square root is not defined. Okay. Yeah, so it will not have square root. I'll just do it another way. It's easier to do this. Yeah. So it passes this test cases, and submitting, will we get time limit exceeded? No. Okay. We got this. All right. So I'll explain the entire code, everybody. Again, I'll explain the entire code. Okay. So let's go step by step. Test case, I'm taking the number of test cases over here. For each test case, I'm taking n as the input. First, what I will do is I will generate all the prime numbers up till n by 2. Why n by 2? Because beyond n by 2, it's no use anyways, right? Who will multiply with that beyond n by 2, right? Those are useless prime numbers for me. Is it clear till here so far why I'm generating all the prime numbers to n by 2? We discussed this already, but is this clear? Okay, 2 people saying yes. What about others? Why we're taking prime numbers up till n by 2? No, sir, for n by 2. Okay. Simply put, I'm trying to get all of the semi-prime numbers less than 20. All the semi-prime numbers less than 20 have to have only 2 prime factors, and their product should be less than 20. What is the least prime number I will get? Less than 20 or any less than any n, I'm going to get 2 as the least prime number. Meaning that the number which is going to be a product is going to be 2 into n by 2. Like for example, let's say I got the number 30. If 2 is a if there is a semi-prime number, and if 2 is one of the multipliers of that semi-prime number, the other number would be 15. Now 15 is not a prime number, so I generate till the last prime number before 15, which is 13. 2 into 13 will be my last semi-prime number less than 30. 2 into 13, which has 2 as one of the multipliers. Okay. If I generate anything more than that, if I let's say generate, what's the next one? The next one is 17. If I generate 17, I get 34. There's no point. And 2 will not interact with it. 3, 5, 7 will definitely not interact with it. Like, because 3 into 17 will be 51. 5 into 17 will be 70. No, sorry. What is that? 5 into 17? 85. Right? 7 into 17 will be 119. Right? So they are all going to be much greater. So if 2 itself cannot combine, let's not go even further. That's why I generated only till n by 2. So if I generate till n by 2, I will generate 2, 3, 5, 7, 11, and 13. That's it. All the semi-prime numbers will fall under this only. Is that clear? There'll be a combination of only this. Now, once I've created all of the semi-prime numbers till here, how did I do that? I started from 2, went till n by 2, and just checked if the number is prime or not. How did I check if it's prime? I wrote my isPrime function. This you should all know by now. If you don't know, please go and revise how you can check if a particular number is prime or not. So please do go ahead and revise that. I appended it to a list. I created a primes list and I appended all the numbers to a list over here. Then now I want to go through this primes list and generate the semi-prime. How do I generate the semi-prime? I multiply 2 into 3, 2 into 5, 2 into 7. I keep doing till I get those products which are less than 30. Then I go again. 3 into 3, 3 into 5, 3 into 7, 3 into 11 becomes greater than 30. Cannot use it. The moment I got 3 into 11 is greater than 30, I stop there. I say there's no point in even multiplying with 13. Same thing, 5 into 5, 25. 5 into 7, 35. Greater than 30. Don't even bother multiplying with 11 and with 13. Okay? Does that make sense? So that's what I'm doing. I'm getting the current number, which is primes I into primes j. If that number is less than n, okay, append it to the semi-prime. If it's not, break out and don't even go on to the next ones. That's what we're doing. Finally, we're sorting the semi-prime numbers because you have to print in a sorted order, and then we're printing it out. Does that make sense? All right, are you clear with this logic of semi-prime numbers? Okay. All right, cool. So I think most of you are. Shall we do it in Java, everybody? Or Java students, you guys understood? You guys want, you'll do it on your own, Java code? You want me to do it? It's clear? Will you implement it on your own, the Java code? Okay, do it. Okay, sure, I'll do it. I'll do it. Awesome. So let's quickly do the Java part. Meanwhile, everyone watching on YouTube, do hit the like button so that others also come to know and others can benefit also. And if you have friends who are missing out on this, please do share this with them. Maybe they're in an exam right now, but you can share it with them later. Will really help them out for these upcoming InfyTQ tests. So make sure you share it with all. Okay. So what do we do? First things first, scanner scan is equal to new scanner system.in. Okay. Then what do I do after that? I take int test cases is equal to scan.next int. I run a for loop for int I equal to 0, I less than tc, I plus plus. All right. So I have this I is equal to 0, I less than test cases, I plus plus. Actually, I'll use another one. I'll say cases because we'll use I cases less than tc, cases plus plus. Okay. Now, what do we want to do? We'll take int n is equal to scan.next int. Okay. Then what do I do with this n? I want to generate all the prime numbers from 2 to n by 2. So what I'm going to do is I'll create an array list because I don't know how many prime numbers will be there. So let me create an array list. So I'll say array list integer, let's say primes is equal to new array list integer, right? So I create an array list. I'll add all the primes to this, right? So I'll say for int I equal to 2, I less than equal to n by 2 because we want to go all the way till n by 2, I plus plus. I want to say if is prime I. How do you append to an array list in Java, everybody? Very quickly, tell me. How do you append? Do you guys remember? Add, very nice. Add I. So if this is indeed a prime number, I'll add it. I'll create another array list for semi-primes. Semi-primes. And I'll do the same thing for int I equal to 0 I less than primes dot size I plus plus, because I want to go to the primes list for j is equal to I, j less than primes dot size j plus plus. Now what will I do? I'll say int current number is equal to primes dot get I into primes dot get j. So I got the element I got the element j, I multiplied them. If this current number is greater than n, then we don't want it. We want to just break out, right? But if the number is less than equal to n, what am I going to do? I'm going to say semi primes dot add current number, and then else I'll say breakout. No point in continuing also. So breakout. Finally, once I come out, I say collections dot sort semi primes, because I want it in sorted order. And let's print out. So for int I in semi primes, I'll say, so can we just form j is equal to 0 by doing tree set? Yeah, I think you guys love tree sets, right? So we can do tree set also because it's stored in a sorted order. Yeah, actually you're right. Instead of sorting it now, why just not use a tree set? Okay, so a lot of you guys like tree sets, right? Let me just use a tree set here. Good one. Tree set integer is equal to new tree set. You're right there. It will store it in a sorted order. So yeah. So then what I'll do is I'll just say for int I. What is tree set? Tree set is a set, but it stores it in it always stores in a sorted order. So it will maintain uniques, but it'll always store it in sorted order. That's what it's going to do. It maintains the sorted order by default. Okay, so for int I in semi primes, I should have done semi primes. System.out.print I plus a space, and at the end let's also print a new line. So we don't need to sort or anything. Okay. Current number equal to n? No. Should be less than equal to. Can we use hash set? No. We cannot use hash set here because hash set is we cannot use hash set because hash set will not store in any sorted order or anything. If we break here, it's only going to break the inner loop, right? So how can we break through both loops? No, we don't want to break through both loops because see, there's 5 will, like for this 3 will combine with itself 9, 3 into 5 is 15, 3 into 7 is 21, 3 into 11 is 33. So I break out here. Does not mean I don't go to 5 into 5. So I'm only breaking the second loop. I'm purposely not breaking into the the first loop. Sir, it is prime, semi-prime when prod equal to none. No. And none of these numbers equal to 30. None of these multiplication equal to 30. It's semi-prime when it is a multiplication of two numbers which is less than or equal to the given number. So it's a semi-prime when we are doing 2 into 3 or 2 into 5. These are both prime numbers. They're semi-prime. We have to generate all the semi-prime numbers less than a given n. So we're saying in general, if you want to break through both loops, okay. If you want to break through both loops in general, while breaking here, put up a flag and then check here if that flag is also true. If that flag is true, you break here also. That's the best way. All right. So this question has one more thing left. We have to do the use prime method. So public static Boolean is prime int n. What do I do for? So if n less than equal to 1, return false, meaning it's not a prime number. If n equal to 2 or n equal to 3, return true because it is a prime number. Sorry, wrong. All right, then what do I do? for int I equal to 2, I less than I into I less than equal to n. This is the fastest way of getting the prime number. I plus plus. If n modulo I equal to 0, I return false. That hey, I got a factor. If through this entire loop I did not get a single factor, I'll return true. Okay. So I'll just run this. J is equal to I should have been int j is equal to I, not just j, int j. Okay, works, and submitting also should work out. Right. Again, the logic is pretty much similar to the Python one. It's exactly similar, the logic. There's no difference. This is a good question. This will come as a question number 2, usually. It will not be your question 1. It will be question number 2. Okay. Is this clear? Distinct numbers window is not updated, or it's not updated. Okay, we'll update it. Don't worry. I'm surprised it's not updated. Okay. Somebody asking a question. Somebody on YouTube asked this question actually. InfyTQ exam, everyone gets the same question, or there are set-wise question which everyone will have different question. There will be set-wise. Everyone will have different question. Even if you have same, don't please do not get into this whole plagiarism thing. You will get blacklisted. And I generally am saying do not get into plagiarism. It's just be honest and go ahead and do it. Like what's up with this whole plagiarism thing? So do not get caught in plagiarism. Do not do plagiarism to get caught in plagiarism. In the long run, only the honest people win out. Don't get into this habit and so on. Just simply do your best. There are many companies out there. If you didn't get in this one, you can get into the other ones. Okay. Somebody said, can we do any method in exam, or is there any priority for good one? No, you can do any method as long as you get the output. It's fine. Okay, somebody's asking. All right, so I'll next go to the rotation instructions. A lot of you are asking for that, so let me just go to the rotation instruction, and then if there's time, we'll go do the generate password. Otherwise, we can take that up tomorrow. Also, we have 2 more classes. There's still a lot of time. Is array list is better than an array? In cases where you have a variable size, array list is better. If cases where you have a variable size, array list is better. Any questions related to bits in, oh no, there are no bit manipulation questions in InfyTQ earlier. Can they ask this time? I highly doubt. But yeah, by the way, how many DSA students here? How many students who are on Edyst DSA? How many of you are on the chat? Any DSA students? Any DSA students? Yeah. DSA guys, this is not sufficient. So just let me take 2 minutes. All the DSA students, look at the constraints, by the way. What are the constraints? 10 and 10 raised to 5. So 10 test cases, and n can go to 10 raised to 5. For each test case, I mean, you can at max do order n over here, right? Because you'll have 10 into 10 raised to 6 probably like, you know, in the worst case, you have 10 raised to 6 computations to do. So you can do order n, and in our case, it's not order n. We have not done that. So DSA students, very quickly, how would you have done a more optimal approach than this? For InfyTQ, this works completely fine. But what's the more optimal approach over here? DSA, any thoughts? Sieve, yep, absolutely correct. You have to use Sieve. But what will you use Sieve for? How will you use Sieve? For prime, correct. But how will you use generate? So the trick here is get the maximum n you are supposed to get. Fine, take all the inputs first, get the maximum n you're supposed to get, generate the sieve only once. Don't generate it 10 times. Generate the sieve only once. Then go through the inputs again and calculate the answer. So go through all the 10, right? Go through all the 10 test cases, because at max you'll have 10 test cases. Get the maximum number that you have. Let's say 1000 is the maximum number. So generate sieve up till 1000. After that, you don't have to generate the prime numbers again. Even then, what we are doing here is an n square approach. Even once you've generated the prime numbers, we are doing an n square approach here. Okay. This is okay because the number of prime numbers you will generate is not that many. You can still do n square on that because the number of prime numbers, this is again another thing to remember. The number of prime numbers in a prime number, up to a number n is, I think, proportional to square root of n. So even if you do square root of n of root n, you will get n, right? So just want you guys to be aware of that. DSA students, don't just do this, what I have just showed you. You cannot check prime number every time. You have to generate the sieve. Okay. All right. Let's go to this rotation instructions really quickly. How to deal with sub-array questions? There's not much to deal with sub-array questions. Like, it's not a specific thing that you have to deal with sub-array questions in a certain way. Yeah. Okay. You're given a string in the format string. Somebody think any better algo than Sieve for prime? There are one or two beyond the scope even of, like, then you have to be like at competitive programming, like at the top level. At your level, Sieve is just more than enough. I forgot the name. What was the name of that thing? There was some wheel method or something. Yeah. I forgot the name of that exactly. But yeah, there is that one method which is heavy on space though. Yeah. Can you please take a sub-array question like sub-array without sum? We'll come to all of that. We'll come to it. I want to take this one. Got a lot of requests for this. Can I do this? Okay. Can I do a rough calculation during the test? Yeah, you can. Just make sure it does not look too suspicious, like you're talking to somebody like that. It'll just look weird, right? So, okay. I think it's wheel factorization. Yes, that's the one. I think it's that one or something else, but there is one more. Anyways, let's come back. You're given a string in the format string num1, num2, and num3. The string can contain characters, special characters, and also numbers. Num1, num2, num3 are instructions to rotate the string. You have to rotate the string to the right by num1 positions, then rotate the string to the left by num2 positions. Finally, remove all the elements that are present at the indexes that are multiple of num3. Let's look at this one. And I'll just copy all the instruction also here so that we are not caught off guard. Okay, so we have to do this. All right. And the example is this one. You have something like this. Hello, welcome to @Python 523. In this, what is num1, everybody? Can you quickly tell me what is num1? 5, very good. Num2, 2. Num3 equal to 3. Okay. Now, what are we going to do? We are going to first, you have to rotate the string to the right by num1 position. So this is a string. If I rotate to the right by num1 position, what does it look like? I'll rotate to the right by num1 position. What's going to happen? I'm going to rotate by 5, right? To the right. So what's going to happen? I'm going to take 1, 2, 3, 4, 5 is going to all come to the start. Correct? This was all rotate to the right by 5 positions. Then I'm going to rotate the string to the left by num2 positions. How do I rotate the string to the left by num2 positions? I take these two and put it here. So far clear, everybody? First step and second step? First step and second step clear? Okay. This was the original string. This is the original string. How can I move to the right by 5? Well, this is how you move to the right by 5. You first move the first one. When I right shift, it becomes this. Then I right shift again. This O goes from here to here. Just imagine like a circle. It's moving. So H goes from here to here. I've so far right shifted 3 elements. Then I'll right shift 1 more element. And then I'll right shift 1 more element. Okay. So these all got right shifted. 5 elements got right shifted. Why 5? Because num1 is 5. Did you get that part? Did you guys understand this? Yes, no? Person who asked me to repeat. Did you? Okay. Then what am I doing? I'm left shifting by 2. How do I left shift by 2? Y and T will go here. Okay. And finally, I will remove all the elements present at num3 indexes. So what is num3 index? Num3 is 3. Sorry. Num3 is 3. If I keep all the indexes, I'll get 0, 1, 2, 3, 4, 5, 6, 7, 8. This will be, yeah. So we can just do it like this. For example, the indexes that are multiples of 3 are this index 0. So H will have to be removed. Then this again, this H will have to be removed. This L will have to be removed. 6, 7, 8. This will be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these will have to be removed. So what you will be left with is ON, EL, OL, EL, OM, 2 at the rate YT, right? That's the output. Yeah. ON, EL, O, I think that's, yeah, it's 1. Sorry, not L. O1, looking same. O1, EL, OM, 2 at the rate YT. Correct, everybody? Understood what we did? We removed all, that is, we didn't print the ones that are multiples of 3. Okay. Cool. So how will we do this? First things first is let's try to take the approach first. So the first approach is take input, right? So you'll have to use all of the techniques we learned yesterday. The split technique, for example, you'll need to take that in order to get like num1, num2, and num3, right? So I took input. Then what do I do? I took input. Then what do I do? I have to rotate the string to the right side by num1 positions and rotate the string to the left side by num2 positions. To the right by num1, to the left by num2. So if I have to take to the right by num1 and left, let's think a little bit before implementing. Let's say the same string, I had to shift right by 10. Let's say right by 10. By 10, I'm giving an example. And left by 8. Overall, how much am I shifting it by? I'm shifting it right by 2, right? Let me give you an example. Let's say I'm having Edyst, okay? And I give you shift right by 4 and left by 1. In effect, what I'm telling you, just do right shift by 3. Why? So let's say if I right shift by 4. So let's say it's EDYST, T comes here, S comes here, Y comes here, D comes here. Right shifted by 4. Let's say I left shift by 1. Okay. This is what? Right 4, left 1. If I directly did right shift by 3, that's it. What will I get? I will get T, then S will come, then Y will come. And then I had ED. This is right shift by 3. Both are same. Both are the same thing. If I right shift by 3. So if I'm doing more right shifts than left shift, basically, if num1 greater than num2, do right shift by num1 minus num2. Are you all agreeing to this part? Does this make sense? Yeah. Okay. Can you please repeat it? All right, sure. Okay. You have, but we can do it stepwise also. No, there's a reason I don't want to. Let's try to think a little bit smarter, right? A little smarter. A, B, C, D. The person asked you to repeat. Can you A, B, C, D? Can you right shift this by 2? Can you please right shift this by 2 and tell me what it looks like? Very good. D, E, A, B, C. Now, can you left shift this by 1 and tell me what it looks like? This. Yeah, very good. Left shift by 1. E, A, B, C, D. Okay. This is what after right shift 2, left shift 1. If I had directly done right shift 1, then what would it have been? Person who asked me to repeat, can you tell me? E, A, B, C, D. Got it? Just think about it, right? I'm telling you, go forward 10 steps. Now I'm telling you, come back 2 steps. You'll be at 8th position. I could have told you directly go 8 steps, right? It's just logical, right? So, all right, let's come back here. So if my right shift is greater than my left shifts, what will I do? I will do right shifts by num1 minus num2. But if num2 is greater than num1, meaning I have more left shifts than right shift, then what do? I do left shift by num2 minus num1. Right? Are you guys getting this clearly? Okay. Can you think of some edge cases here? We have not thought of all cases. Can you think of some edge cases here? If left shift equal to right shift, don't do anything. Yeah, you tell me. If both are equal, obviously we don't do anything, right? You left shift and right shift the same amount. Very nice. Somebody has actually thought of a thing. Very, very good. So let me give you the edge case. Let's say I give you the string Edyst. I tell you right shift by 40, left shift by 12. And then probably, 3. 3 is what you have to print. That's fine. The num3 is fine. But right shift by 40, left shift by 12. How much do I have to right shift by over here? How much should I have to right shift by over here? Or left shift? What should I do? Is num1 greater than num2 or num2 greater than num1? Like what is it finally telling me to do? Very nice. Here I'm saying right shift by 28. Right shift by 28. Not 18, 28. Yeah. How do I right shift Edyst by 28? Or what does right shifting Edyst by 28 mean? It is the same thing as, some of you have got it, right shift by 3 is the same thing as that. Because if I did Edyst right shift by 5, what will I get? I will get Edyst only. It will come into one circle. Right? So I'll do it by 5, same number. Again 5, same number. By now I've done 10 times. 5, 5 again, 20 times. And 5, 25 times. So after the 25th right shift, basically, it will again come back to Edyst only. I'm left only with 3 right shifts then. Okay. Are you guys getting this? So if the number is bigger, that is, I have to do 28 write shifts. Instead of actually doing 28 write shifts, that would be foolish to do, right? Why would I say, let's say 28 is still fine. Let's say it is saying 1000 write shifts, or let's say 1003 write shifts. Why would I do 1003 write shifts of Edyst? Of that 1003, the first 1000 will get me back to Edyst only, or the original string. It's going to get me back to that. It's only 3 write shifts that I need to do. Got it? Yeah. So what I'm going to do is, now can you modify this? Do write shift by num1 minus num2. Instead of num1 minus num2, what can I make it? Shift by the remainder. So num1 minus num2 modulo len of whatever the word is. Right? If there are multiple of string length shifts, then it gets same. Yes, you're absolutely right. That's exactly what I'm saying. Do left shift, or you do left shift by num2 minus num1 modulo len of word. Same thing for left shift as well. Same thing for left shift. All right. Is that clear? Okay. The only thing that's remaining is to actually do the right shift and left shift. That is, we already saw that earlier, how you can do that. So I'll just quickly go into the code. So let's first take the input. So let's say, yeah, you can do right shift and left shift by taking substring. So let's say word is equal to input. Not even one. Let me just take overall is equal to input. And what do I want to do? I have to split by the colon, right? So this is the cleaning part. I'm going to split by the colon. The word is going to be overall 0, the first element of that string. My num1 is going to be int of overall 1. My num2 is going to be int of overall 2. And num3 is going to be int of overall 3. Okay. Because I split it as per the string. So I'm going to get it like that. Yeah. All right. After I've done with that, what will I do? I will just try to see if num1 greater than num2. I will answer, and I'll just say answer is equal to word over here. So answer is equal to word. I'll say answer is equal to right shift. I'll write a program called, I'll write a function called right shift. Num1 minus num2 modulo len of word. You have to right shift which one? You have to right shift word by this much. Right? And else, let's say elif num2 greater than num1. What am I going to do? Answer is equal to left shift word num. 1 second. Let's not miss out on the brackets. Like this. Num2 minus num1 len of word modulo len of word. Okay. Cool. I have to just write right shift and left shift, right? That's the only thing I need to do. And yeah, then when I print the final answer, I have to ignore all of those indexes that are divisible by 3 or divisible by num3. So for I in range len of word, while printing, I just need to make sure that if I modulo num3 equal to 0, don't print it. So if I modulo num3 not equal to 0, I can print word of I and is equal to this, and then I'll just print a new line after this. Okay, Cool. So I just need to write right shift and left shift. So let's do that. Define right shift. I will take a particular word and I will right shift it by, let's say, X. So if I want to right shift it by X, what do? I take the last X elements. So I say word is equal to word. I'll take the last X elements and put it at the start. And the first element till the X element, I'm going to put at the end. So start from the starting till X comes till the end, not including X. And the last X element, so that's going to be, sorry, no, this would be wrong. I'm sorry. I want to right shift by X, right? So I want to take the last X elements. Last X elements would mean which one? Len of word minus X onwards, right? So I want this one all the way till len of word, right? I'm going to take these last X elements and add it to word of starting up until len of word minus X. Okay. And then I'll return this word. Similarly, if I do left shift word comma X, so left shifted by X, what will I do? Word is equal to, I'll take the starting X elements, but they have to be at the end. And X onwards has to be at the start. So word X onwards has to be at the start. Yeah. Finally, I can return word over here. So this would be left shift. Let me run this. All right. We are not getting the right shifting properly. Didn't work out. Second. Okay. We should be printing answer of I, not word of I, answer of I. Yeah. This works out. And if I submit it, all right, we are still getting left shift is not defined. Left shift is not defined. Did I make a mistake? Oh, wrong spelling. Comically wrong spelling. Yeah. All right. Good. Now it's working. All right. So is that clear? String rotation. Does that make sense? Does the string rotation part make sense to everybody? Do you want me to repeat any particular part? If it's clear, to say clear. I'll do it in Java also, but let me know if this is clear for the Python students. Okay, let's quickly do it in Java. I know you're all tired as well. So let's just quickly do it in Java and call it a day. So okay, once explain num1 minus num2 modulo len for num1 equal to 5, num2 equal to 2. Okay, yeah, that's simple. So for example, this case only, num1 is equal to 5, num2 is equal to 2, let's say, right? So I want to right shift by 3. So num1 minus num2 is equal to 3. I have to right shift by 3. But I'm not just doing right shift by 3, I'm doing right shift 3 modulo 5. What is 3 modulo 5? What is 3 modulo 5? 3 itself, right? So I'm right shifting by 3. That's the point. Modulo with a number less than the length will anyways give me the less than the length. For a number greater than the length will give me a number less than the length again. Got it? Did you get that? Understand it? Super. Okay. Java.util.sar. Okay. Public static void main string args. All right. What do? We first start with string overall. Second, even before that, scanner scan is equal to new scanner system.in. String overall is equal to scan dot next, and we'll split it. So we'll say string, let's say inputs is equal to overall dot split by the colon. So I'm going to split it by the colon. Now string word is equal to inputs of 0. String word is that. Now num2, sorry, now int num1 is equal to inputs of 1, but I need to convert it to an integer. It's a string. How do I convert it to an integer, everybody? Please tell me. Meanwhile, I'll do this. Right? Can anybody tell me how do I convert this to an integer? Very nice. Integer dot parse int. Convert all of this to an integer. Okay. After I've done that, I've converted each to an integer. I check if num1 greater than num2. What will I do? I will say, let me create a string answer also. String answer is equal to word. Answer is equal to right shift word by num1 minus num2 modulo word dot length. Length with the brackets because it's a string, and the opposite will be the case over here. If num2 greater than num1, left shift word by num2 minus num1 modulo word dot length. Finally, I will go through for int I equal to 0, I less than answer dot length I plus plus. If I modulo num3, so if it's divisible by num3, so this is divisible by num3, related to system dot out. If it's not divisible by num3, I'll print out answer. I want to print out the particular element at that point. How can you print out the element? I think I can just do caret, right? Caret I. Right, let me just do that. Yeah. And then do system.out.println. Okay. Right shift and left shift, I have to define now. That's the only thing that's remaining. So I have to define this right shift and left shift. Public static string right shift string word and int x. All right. So I have to shift it to the right by x. Same thing as how I did it in Python. I'll say string word, or rather word is equal to, if I have to right shift by x, what do? I have to take the last x elements. So what do the last x elements be? I'll do word dot substring. I have to take the last x elements. So I'll say word dot length minus x onwards, right? So as I told you last time, in Java, it will by default take onwards. Okay. So start from minus x onwards, take those and add it to word dot substring, starting from 0, going up till this, but not including it. So going up till this particular index. Right? And then I'm going to return word. Okay. And if I have to do left shift, public static string, because I'm returning a string, left shift string word int x. So what I'll do, I'll say if I have to do left shift, I take the first x elements. So I'll take word dot substring. I have to take the first x element and I have to add it at the end. So how to take the first x elements? I will say from 0 up until x, take those elements, but this has to be at the end. So then I'll take the remaining elements. So that is, what is that? Word dot substring x onwards, x index onwards at the start, and then from 0 up till x at the end. That's the left shift. And again, return word. Okay, so that's the right shift, that's the left shift. Again, just revising. Line 6 is it? Line 6. Word dot length, word dot length. What about word dot length? Did I miss something? Line 6, you're saying word dot length. Am I missing something? Comma. Where is the comma? Line 6 here. This comma is what you're talking about. No, you don't need a comma. This is the just for Java students. This is if you ever ask if somebody asks you about polymorphism, this is a great example of polymorphism, in the sense that if you give only one parameter, if you just give one parameter, then all it will take is it will start at this index and go till the end. It will by default go till the end. If you give two parameters, then it will start at the first one and go till the last parameter, not including the last parameter. Okay. So you don't need to give a comma over here, just like I didn't need to give a comma at this also, because I think start at X and go till the end. That's what I'm saying. So when I don't give a second parameter, I'm saying go till the end. Okay. All right. So let's again just revise the entire thing. Let me actually run it and see if it's working. Yep. Okay. So explain num1 greater than num2 and num2 greater than num1. I already explained this twice. If you can just rewind this and see, I already explained these two twice. The reason, again, that was the entire point of this entire question. So kind of already explained it twice earlier. If we just rewind and check, you'll get it. All right. So just revising again. Took the input. When I take the input, it is in the form of string num1, num2, and num3. They're separated by colons. So I split it by colon. When I split by colon, I get an array of inputs. What will I do? The first input is going to be string. The next all need to be converted to an integer. So what I'll do is I'll say, okay, if num1 is greater than num2 means I need to right shift. And if num2 is greater than num1, it means I have to left shift. Right? And since you're asking, I'll also just repeat it. I don't like it when someone asks and I don't repeat. So I'll just repeat it again. Simply, I was telling you like this. If Edyst is there and I tell you right shift by 4 and then left shift by 1. Right shift by 4 and left shift by 1. It is the same thing as doing right shift by 3. Same thing as doing right shift by 3. Edyst. If I right shift by 4, what's going to happen if I right shift by 4? First one, I'll get dyst. Sorry, right shift, right? I will get, so when I right shift by 1, I'm going to get tedys. Then I'm going to get sted. And then you'll get ysted. Right? This is right shift by 3. And then right shift by 4 will give me dyste. Right? Is what I'm going to get. So this is the first right shift. First right shift, second right shift, third right shift, and fourth right shift. And then I'm told left shift by 1. So when I left shift by 1, I again end up at ysted. So it's basically like I was saying, I tell you walk forward 5 steps, come back 2 steps. The same thing as saying go forward 3 steps. That's what I did over here. Right shifted by 4, left shifted by 1. Hence I'm doing right shift by 3. That's what this condition is also for. If num1 is greater than num2, right shift by num1 minus num2. Did you understand that? Person asked me to repeat. Did you get that part? Okay. And the same thing with num2 greater than num1. Now, why did we take modulo word.length? Because it could so happen that I tell you right shift by, let's say I tell you Edyst right shift by 25. I will get Edyst only. Why? Because right shifted once, 5 times will get me Edyst. Again, another 5 times will get me Edyst because it's a multiple of 5. And that's the length of the string. So I took modulo this, that is whatever is the remainder on division by 5 will give me the correct answer, right? So that's what you're going to get over here, right? So I did right shift by that much, left shift by that much. And finally, when I'm printing out the, I see that is the index divisible by num3. If it is divisible by num3, don't print it. If it's not divisible by num3, then print it. Why? This is the requirement of the question. Just revising the right shift part. What am I doing right shift? Take the last x elements. So start at word length minus x onwards. And then that has to be at the start. And then this part 0 up till word length minus x will be there. In the left shift, what do? I take the first x elements and put it at the end. And from x elements onwards has to be at the start. Okay. Just trace out these codes. You'll get it. So a lot of people asking for question links in the chat. My team will help you out. But if not, if you can check out the link in the description on YouTube, rather, somebody's asking YouTube. So if you're checking the link in the description, it has the link to the actual course, so you can check it out over there, right? So it's there in the description, and my team can also help you out on the chat. Okay. All right, everybody. Any last doubts on this? Any last doubts? If it's all clear, please say clear, and we'll wrap up for today. Unshow code. Yeah, please try it on your own systems. Yes, yes. For now, please do try it on your own systems. Subarray division with odd sums. 1 second. Let me just check that question. Oh, okay. Let me check this question. The one you have. I'll give a hint for it. Number of subarrays with an odd sum. Okay, since it's a subarray, it means it's always going to be taken in continuous. 5, 4, 5, 4, 4, 5, 4, 4, 5, 5, 4, 4, 1, and 3. You just have to generate all the subarrays over here. That will be the simplest way. So basically for index 0, go up to index 1, then index 2, then index 3, then index 4, and then index 5. Then for index 1, go up to index 2, index 3, index 4, and index 5. Right? Then for index 2, go to index 3, index 4, index 5. Right? At each time, keep taking the sum of the numbers. That would be the hint. When you take the sum, you will check if it's odd or even. If it's odd, then increase the count. If it's even, then don't increase the count. Okay. Others, all clear? In InfyTQ sample test, I have attempted a question where 4 test cases passed out of 6. I have checked all the edge cases. How do I manage there? You missed out a couple of edge cases. That's all. The best edge cases to check for are 0, -1. What if the array is empty? Are you dividing by a negative number? Are you multiplying by a negative number? Those are the major edge cases. And then after that, it depends on the question to question. Summation calculators 3 by 4 test cases passed. What is the edge case? I mean, post it on the forum. We'll check it out, or ask the mentors. They'll help you. I have to check your code. Then only I'll come to know. Right. Okay, cool then. Do we get TLE in InfyTQ cause InfyTQ brute force module solutions working? You will get time limit exceeded if you're going to infinite loops. So it's not like time limit cannot come. Time limit exceeded is possible. Very rare though, but it is possible. If you are doing infinite loops. Otherwise, mostly you should not get. In InfyTQ at least, you should not get. Okay, cool. We'll pause here. We'll continue again tomorrow. So see you all tomorrow. All the best for tomorrow's mock test. And yeah, I'll catch you all tomorrow then. Thank you so much for joining here. If you liked these tutorials, do make sure you leave a like on the YouTube channel for this very same tutorial, and also subscribe to the channel if you have not yet. Really love to hear from all of you. And we want to release some really cool videos as well. So please make sure you're sharing it there also. Share your feedback there as well. In exam, we got the same questions, or else there will be sets for all. There will be different sets for all. Somebody's asking. There will be different sets. Some might be overlap, some might not be. Yeah, but difficulty will be same for all, roughly. Still, don't go for plagiarism, as I said again. Not at all useful to do that. Okay. All right then. Thank you so much. And I'll catch you all next time. All the best.